Okay, let me continue. So that's how I personally, I am not speaking for other teacher. I am speaking for myself. Okay, that's how I would evaluate you. Okay, so any question, you can ask your question now. You can suggest anything now. Okay? You can suggest.
Sir, good afternoon, sir. Pero can I suggest, sir, just to contribute, sir, para sa introduction po ng mechatronics.
Okay.
Sir, pero po kung magpagkita ng mga ano po, pang mechatronics po na like sa mga PLC po, like sa mga cylinder, sa PLC, sa power supply, push button, stop button. Kasi sir, nasa training po ako ng mechatronics sa TESDA, sir.
Siguro I can give you a chance if you would like to contribute to that. No? But because we have limited time, I don't know if let's see. It's too early to say. It's too early to say. I will decide on that. I am just discussing with you
So,
an orientation right now. So I am very much aware of
so ito po sir yung ginagamit po namin PLC, yung Mitsubishi.
Okay. So
then ito po yung mga push button sir, which is yung start, stop, and yung emergency stop para po dun sa makina namin na cylinder. So ito po yung ginagamit ng LED, yung red, kaso sir hindi pa namin napapaandar. Then ito yung sensor. May sensor po dito sir na connect para dito sa cylinder na to. Kapag meron siya na-detect, na-sense, tataas tong cylinder. So mag-ano siya, magre-retract. So some sir, meron din po kaming ginagamit na motor. Sir, ang tawag ng motor nito?
Sige, pandarin natin.
Sir, pandarin mo sir.
Lagyan ng workpiece. Ayan ang workpiece.
Mandar na kagad?
Oo, mandar.
So ang nangyayari kasi sa troubleshoot pa po namin yung ginawa namin. Ibalik mo na.
May adjustment pa kasi ginawa namin. Detect meter. Stop.
So ito yung isa sa ginagamit na relay, yung relay namin.
Para sa BFD yan.
Tapos yung breaker, yung power supply, PLC, tapos po yung ang tawag dito, terminal block para sa PLC. Tapos yung mga push button sir. Isang sir, isang cycle po sir. So, ayan lang sir, yung gusto ko lang po i-share sa amin, sa klase ko po sir, sa klase niyo.
okay, sige, good. That is one application ng one application of mechatronics. Okay? So we will explain in this course. We'll explain more on the principles, concepts behind those things. No? So it's important that you already saw an example, a particular example. So he said about something about cylinder, said about something relay, push button, PLC. What are those things? What are those things? What we can say and how to describe it? How they connect with each other, how they work, right? So we can do it properly and in engineering perspective. In engineering perspective. So that there's a difference. There's a difference between engineering, which will think about the system as a whole and analyze it as a whole, design as a whole, using our previous knowledge on our several subjects. For example, you can do that application in one area of mechanical, like for example, refrigeration, in air conditioning, in power plant, in industrial equipment, okay, and automation. The application that he showed us is actually industrial. Okay? That is actually industrial application. So we can discuss it in a very scientific, procedural, and engineering perspective. So, by the way, since we do not have laboratory, you can always go to like that. There are scholarship for that, free tuition, no? So, and TESDA is just what? Having their office, main office, national office in Taguig. So there are plenty of things you can take up on TESDA because we do not have laboratory equipments, okay, in our school. So because of that, you can choose to take a look at opportunities in TESDA. That's why it is very important. Somebody showed us maybe there are still scholarship available. There are plenty of trainings in TESDA, okay? And that is for the purpose of what? Laboratory. Okay. Anyway, our mechatronics course, going back to our discussion, is a lecture only in 2 hours. We do not have laboratory part. No, we do not have laboratory part. I don't know why, because in other school where I taught for so many years, we have laboratory and we are complete with what? With equipment like that. We are complete with equipment like that. After discussion, after lecture, we will go to the lab and realize our principle, our discussed program, okay? Simple programming. Okay? But still, we can do it in real laboratory setup. I don't know, because maybe we don't have laboratory. That's why they totally take out the laboratory part of the subject. So I cannot do anything about that because I am just a teacher. I will just follow what is written, what is my authority. So that is what I am telling you. So even if I am a referee or I am a judge, the judge authority has a limitation. Because if you are a singing contest judge, you cannot give your take or you cannot give your evaluation on beauty contest because you are just a singing contest judge. Okay, if you are a referee in boxing, you cannot referee in basketball. Okay, so that is the limitation. So I am only given the authority within the boundaries of the subject. Okay, within the boundaries of the subject. All about the subject, I am the responsible person. So my evaluation of you individually matters, and I would like to evaluate you individually. Okay, so that's all about how would you like to get your grade, how to pass this course, and therefore I will just see you next meeting because I will work to put more details on our subject because this is a different one. This is a new one, new curriculum. I handled mechatronics subject for so long. I started mechatronics 1993. Okay? I practically so many actual real job application of mechatronics. And there are many things that looks like that one mechatronic application that somebody showed us. Okay, that is a PLC. That is a PLC, and PLC is what we call programmable logic controller. Programmable logic controller is a industrial computer with all the elements of a computer. Okay, so those things I need to gather because I need to create something that would be fit into a 2-hour per week version of the course. Okay, so this is the first time I will handle this course in the new curriculum. Your new curriculum meaning you are all coming out from K to 12. So this is the new curriculum. This is the first time I will handle this for the new curriculum, and maybe that is also the reason why this course is only two hours because it is new curriculum. Okay, so engineering become 4 years from 5 years, and mechatronics become 2 hours from 4 hours. I am handling this course in other school 4 hours, 3 hours lecture, 3 hours laboratory. Okay, so we are doing those things in the lab with the students. Okay, so maybe because K to 12 graduates are prepared enough, are good enough. That's why you can digest all of those things in 2 hours rather than 4 hours or 6 hours. In other school, this is 6 hours because 3 hours lecture, 3 hours lab, 6 hours. So it is very difficult for me to give you all about mechatronics in just 2 hours. So it's very difficult. No? So anyway, what will you do? So you need to look for opportunities like TESDA, because we don't have the luxury of equipments and devices in our laboratory. In fact, we do not have laboratory. But don't be discouraged. About 60 to 80% of schools do not have laboratory like us. And they become engineers. They become engineers. Oh. Okay, so they become engineers. We are very far. We are very far from other school. Like, for example, in Japan. Do you know that I studied mechanical engineering in Japan? I am a graduate of Japanese University. And in Japan, we have plentiful of equipments and devices like that, no? So lathe machine, milling machine. One student, one milling machine. One student, one lathe machine. One student. On our third year, we can do a robotic application. We can do a CNC machine. Okay? Here in the Philippines, a graduate of engineering can barely see a CNC machine. But in Japan, we can make our own CNC machine in our fourth year. That's the difference, no? That's the difference. We have what? We have conventional machines on first year. On second year, we have what? We have special machines. On third year, we have what? CNC machine and machining centers. Machining center. And then on our fourth year, we have what? We have wire cut. We are wire cut machine, and we have laser machining. So
Pwede magtanong, sir.
we have a long way to go in the Philippines. So don't be discouraged, because 60% to 80% of our school in the Philippines do not have laboratory. And we are all victims of that. We are all victims of that because our country is not so great. Our country is not so great compared to what? Japan. Compared to what? Europe, United States. So we have to use whatever we have just to learn. So by following, for example, CHED. So we are following CHED so that whatever lacking in equipment, devices, we can add on to your knowledge. Okay? Even UP, I am a teacher in UP previously. Before I went to TCU, I am a teacher in UP. Okay? I am an engineering teacher in UP. That's why I know that they also lack several equipments, machine. Okay? So if UP lacks something, much more the other school, particularly those schools in provinces, in the province. Okay? So there are only a handful of schools that have particularly well and good in providing laboratory equipments for their students in the Philippines. No? So let us not compare it to Japan. Let us not compare it to US. But be proud and be encouraged that you have this opportunity to learn. Okay? Even at least you have to imagine those equipment. We are just imagining things, but we become engineer. Okay? So it doesn't matter what we are going to do. What I'm going to do is to prepare you for your future career, for your future job. No? Just like what I've said, this is a job-related course because it is a specialized course. So I cannot help you with equipments, but there are several opportunities. We already have several students who took free trainings in TESDA. TESDA is very good, and also MIRDC or DOST. There are free trainings for students. So you take advantage of those opportunities, and they are free. And sometimes they even give you allowance. They even give you allowance or scholarship money. Okay, so the way on how we learn engineering, the way on how we study right now is too much, hundreds of times easier than before. It's very hard to study engineering before. The resources are almost always available online. The knowledge part available online. No? So you can search almost everything. So I am just looking for your attention. So pay attention when we are talking, when we are giving you the lectures in the future, next meeting, and so on. You have to listen because we don't want to waste your time. I don't want to waste my own time. Okay? We have to deliver properly according to the requirements of the course. Okay? So that means we will proceed. I already have some idea. I already have something prepared actually. Okay, but I will reserve it. Next meeting we will start properly. I already have several books here that we can use for this course. Okay. So I may show you one or two of these. Okay, so let's show you this as an introduction. So I may share it to you. So introduction to mechatronics. This is one chapter as an introduction. So we can design about 5 to 6 chapters only because this course is only having 2 hours per week. So let us just do it like this. So as an introductory material, what mechatronics is all about. It is a term actually coming out from Japan. So Japan is actually a country which is the most industrialized one in the world. Very small compared with United States, very small compared with Europe, but very big compared with everybody in terms of technology and in terms of economy. So Japan is the 3rd largest economy in the world. Okay? So the name mechatronics was from Japan, no? Coined by Kikuchi President of Yasakawa Electric Corporation at Chiyodaku, Tokyo. So Chiyodaku, Tokyo, actually, I sometimes visit this place. We have some favorite areas in Tokyo area where we always visit, and this is one of them, Chiyodaku. So he coined the word mechatronics by combining the term mechanics and electronics. Right? I am actually a licensed mechanics instructor in Japan. I am a licensed mechanics instructor in Japan. I am a licensed mechatronics instructor in Japan. I am a licensed heat treatment instructor in Japan, and also a licensed plastic deformation instructor. So I have 4 licenses in Japan. So I did not. I am qualified as a production engineer in Japan, but I did not apply. I did not renew. So that is my licenses in Japan. No? So from mechatronics came out from the root word mechanics and electronics. What do we mean by mechanics? Mechanics means all things mechanical with mechanism. That is how Japanese define mechanics. So in the Philippines, Tagalog, mekaniko, no? Mekaniko. So in Tagalog, that is mekaniko. So I am a licensed mekaniko instructor, Japan. Mechanics meaning you have the ability to operate, handle, maintain, and teach everything about mechanism. Okay? That is mechanics instructor in Japan. Okay? Okay. And the other word is electronics. So mechanics and electronics become mechatronics. Electronics is all about small pieces wherein we can use to communicate, control, manipulate by use of electricity, electrical signals. Electrical signals in reality, in real world application, when we say signals, very small amount of voltage or current. Small current, small voltage. That is what we mean by signal. Okay? Signals could be in the form of current, could be in the form of voltage. Okay? So we will take a look at the actual practice. So integration of electronics, control engineering, and mechanical engineering. So afterwards, it becomes this big, no? It involves mechanical engineering. Beforehand, it only involves mechanics. Mekaniko lang, no? Mekaniko lang before, no? Ngayon, it involves mechanical engineering. Because of what? Of the so many mechanical elements, mechanism, okay, that could be used in order to produce a mechatronics application. Okay, so there are so many things that we saw a while ago. Okay, as an example of mechatronics application. So application of complex decision making to the operation of physical system. So decision making meaning in terms of what? Electrical signal. So that is electronics. No? Synergistic integration of mechanical engineering with electronics and intelligent computer control. Synergistic meaning 1 + 1 is equal to 3. Huh? So why? Supposed to be 1 + 1 is equal to 2. But because of synergistic integration, meaning the integration gives us another form of advantage. That's why in not only two advantages, not only if you combine electronics and mechanics, you can just have two advantages, one from mechanics and one from electronics. But because of the combination, there is another advantage that is born out of it. So that's why 1 + 1 is equal to 3 sometimes, no? So it depends on the one who will what? Who will design the mechatronic system. In the design and manufacturing of industrial products and processes. Okay? So synergistic use of precision engineering. Oh, this is very much Japan. This is very much Japan. There is no precision engineering in our country. So actually, this is my major subject when I took up mechanical engineering Japan, control theory, okay, computer science, and sensor and actuator technology. So these are being exposed to you from what? TESDA, no? Technologies. Okay? Take note, engineering practitioners involves 3 types of person. They are all inside mechanical engineering profession. What are those? Who are those? CPM, no? CPM is actually our mechanics, our mechanico, no? Mechanics and technician, they are involved in mechanical engineering practice. They are called mechanics or technician. Another one are those technologists. Technologists, mechanical technologists. They are those persons who are skilled in operating machines, equipment. No? They are skilled in connecting or integrating, just like what we have shown a while ago. Okay, the application of mechatronics that we are shown a while ago. Those persons who are connecting those pieces into one unit, into one useful unit, they can be called as mechanical technologies. Okay? And lastly, those who are mechanical engineers, which are particularly interested in research, design, and analysis. Okay? So those are the 3 mechanical engineering practitioners. So they are having their own part in mechatronics. Okay? Because of what? Here, different methodologies. Okay? For example, a methodology used for optimal design of electromechanical products. Methodology. So there are contributions coming out from different persons. Okay? In order to what? To give you a full system. Okay? Field of study involving the analysis, design, synthesis, and selection of systems that combine electronics and mechanical components with modern controls and microprocessors. So we are now involving microprocessor in our mechatronics, and not only microprocessor. Nowadays, actually, one of the subject I taught in one school, I am not only teaching PLC. We have a real PLC, and we are programming the PLC, and we are connecting the PLC to input and output, and push buttons and like that. No. As a student, they are very much interested also in programming not only the PLC, but the Boolean controllers and processors and computers, industrial computers. So we have what? Different languages. For example, if you are using, a while ago, we are shown a PLC made by Mitsubishi. Usually, Mitsubishi PLC are Milsec model. So there are several models. There are several PLC manufacturers in Japan, like Omron, like SMC. So there are several. There are so many PLC manufacturers in Japan. So, and there are different types of programming, levels of programming also. And one of which, very high level of programming, using laptop, we can use already the laptop in order to program the PLC. So those are things that we say methodology. There are so many methods, not only one. No, there are methods by this person. There are methods by another person. There are so many things. There are so many methods. Why? Because there is no standards yet in mechatronics. So there are plenty of manufacturers that would like to create standards. Very important is standard, because, for example, in computer system, there is too much standard. How did we know that there is too much standard in computer system? Because you can buy any brand of what? Any brand of mouse. You can buy any brand of mouse, and you can use that mouse in any brand of laptop, in any brand of desktop, in any brand of equipment. However, that is not particularly true when we are talking with PLC. There are some brands that could only be used in specific brands. Okay? So because the level of standards in PLC system is only up to what? Protocols, communication protocols. So not yet on the level of application like in computer. Okay, so mouse is an application, no? So mouse is what? Plug and play. Mouse is a plug and play application, while PLC is what? Protocol on the what? Lower level communication in the data communication system. So that is one thing. So mechatronics working definition for us. Mechatronics is the synergistic integration of sensors. So meaning to say, collecting the different definition above. There is no single definition of mechatronics as of the moment. I will show you later on a textbook, mechatronics textbook, dated 2019. 2019 is the date. I even have so much. I even have mechatronic system book. Okay.